We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live.
Mysterious objects have always fascinated humanity, but the fascination turns into unease when something appears suddenly in our cosmic neighborhood, and no one can say with absolute certainty what it really is. In 2017, scientists detected a fast-moving object slicing through the solar system that did not behave like anything they had ever observed before. Some believed it was nothing more than a strangely shaped rock, while others suggested it could be evidence of alien technology. Years later, history appears to be repeating itself. In July 2025, a new interstellar object designated 3I Atlas was discovered, and almost immediately it became the subject of alarming rumors. Claims spread rapidly online that NASA insiders had leaked terrifying images of the object, shocking astronomers and suggesting that something far more disturbing than a simple comet was unfolding. The question many began to ask was simple but unsettling. Is 3I Atlas merely a harmless cosmic visitor? Or could it represent the strongest sign yet that something unknown is passing silently through our solar system? The object known as 3I Atlas did not simply appear out of nowhere. Long before humanity ever looked up at the stars, it was already on its journey, drifting through the cold emptiness between stellar systems for millions, possibly billions, of years. Astronomers believe it was ejected from its home star system during the chaotic early stages of planetary formation, when gravitational interactions between giant planets can fling icy debris into interstellar space. For untold ages, it traveled alone through the darkness until chance and gravity carried it into the vicinity of our sun. When astronomers finally spotted it in early July 2025, they immediately knew they were witnessing something extraordinary. This was not a typical comet born in the outer reaches of our own solar system. It was the third confirmed interstellar object ever observed, following the enigmatic Oumuamua in 2017 and the interstellar comet Borisov in 2019. Scientists designated the object 3I Atlas, with the 3I indicating its status as the third interstellar visitor ever confirmed, and 3I Atlas referencing the asteroid terrestrial impact last alert system that first detected it. From the moment of its discovery, 3I Atlas captured intense global attention. In all of recorded astronomical history, only two such objects had ever been identified before. Now a third had arrived, and it was already behaving differently. Early observations suggested that it was brighter, larger, and more active than expected for an interstellar object. Many astronomers initially assumed it was simply a comet on an unusual trajectory. However, as additional data poured in, it became clear that something about its motion did not align with typical solar system objects. When scientists calculated its orbit, the results were unmistakable. The path of 3I Atlas was hyperbolic, meaning it was not gravitationally bound to the sun. Its eccentricity was measured at roughly 6.2, far exceeding the values seen in previously observed interstellar objects. By comparison, Oumuamua had an eccentricity of about 1.2, while Borisov measured near 3.6. This alone confirmed that 3I Atlas originated far beyond the influence of our sun. It was racing through the solar system at nearly 60 kilometers per second, more than 130,000 miles per hour. At such a speed, no planet or gravitational interaction could capture it. The object was not here to stay. It was passing through, destined to return to the vast expanse between the stars. Yet speed alone was not what alarmed scientists or fueled public speculation. What truly stood out was the object's brightness and apparent size. Preliminary estimates suggested that 3I Atlas could be between 1 and 2 kilometers wide, making it significantly larger than Oumuamua and possibly larger than Borisov as well. Unlike Oumuamua, which showed little to no visible outgassing, 3I Atlas quickly developed a faint coma and tail, classic signs of cometary activity. This indicated the presence of volatile ices sublimating as the object warmed under the sun's radiation. To astronomers, this was thrilling. It meant that 3I Atlas was likely an ancient, relatively pristine remnant from another planetary system, offering a rare opportunity to study alien chemistry without leaving Earth. As telescopes around the world focused on the object, scientists realized they were observing something akin to a time capsule. Interstellar objects preserve the chemical conditions of their birth environments, frozen in place for eons. By analyzing the gases released by 3I Atlas, researchers could infer details about the temperature, composition, and radiation environment of a distant star system long gone or far beyond our reach. Some of the more extreme rumors suggested that 3I Atlas was emitting its own radiation, not just reflecting sunlight or releasing heat. These claims pointed to faint infrared spikes detected in early Webb data. In reality, such spikes are well understood as emission lines from excited molecules such as carbon dioxide and carbon monoxide. When sunlight energizes these molecules, they emit light at specific wavelengths, creating the appearance of unusual energy signatures. To trained astronomers, this is textbook comet physics. To those unfamiliar with spectroscopy, it can appear mysterious or even artificial. The shadow of Oumuamua loomed large over every discussion of 3I Atlas. In October 2017, Oumuamua was detected on a hyperbolic trajectory through the solar system, becoming the first known interstellar object ever observed. Unlike 3I Atlas, it showed no obvious coma or tail. Even stranger, as it passed near the sun, its speed increased slightly in a way that could not be fully explained by gravitational forces alone. Perhaps the most astonishing aspect of 3I Atlas is its potential age. Based on its composition and interstellar trajectory, some scientists estimate that it could be as old as 7 billion years, making it older than the sun itself. If true, this would make it the oldest comet ever studied, a relic from an era when the Milky Way was still forming many of its stars. Each molecule released from its surface is a message from a distant past, offering clues about the environments in which planets and life might arise elsewhere in the galaxy. Despite these compelling scientific explanations, speculation about extraterrestrial contact continues to captivate the public imagination. The idea that an object from another star could be watching Earth or carrying unknown technology is deeply ingrained in popular culture. Yet there is no evidence that 3I Atlas poses any threat or represents anything other than a natural comet. Its closest approach to Earth will be more than 150 million miles, far beyond any danger. It will pass closer to the sun in late 2025, but still at a safe distance before accelerating back into interstellar space. The true significance of 3I Atlas lies not in fear but in opportunity. It reminds us that our solar system is not isolated, that material from other stars can and does pass through our cosmic neighborhood. Each interstellar visitor expands our understanding of the galaxy and our place within it. While rumors of insider leaks and hidden images make for compelling stories, the reality is far more profound. Through careful observation, rigorous analysis, and international cooperation, scientists are learning to read the messages carried by these ancient travelers. As 3I Atlas fades from view and continues its lonely journey back into the dark, it leaves behind more knowledge than mystery. It challenges us to refine our models, improve our detection systems, and prepare for future visitors that may arrive with even more surprises. Whether or not humanity ever encounters evidence of extraterrestrial intelligence, objects like 3I Atlas ensure that the universe remains a place of wonder, complexity, and endless discovery.